Hello, good morning, everybody. Welcome to the historic campus of the Indian Institute of Science at Bangalore. This institute was established in the year 1909, and currently I am in front of the first building that was established at Indian Institute of Science, that is the institute's main building. My name is Bikramjit Basu. I am currently professor at Indian Institute of Science. My primary affiliation is with Materials Research Center. And I'm also associated with other departments, that is Department of Design and Manufacturing, as well as Interdisciplinary Center for Energy Research at Indian Institute of Science. So today I'm going to introduce you to the new NPTEL course on additive manufacturing, process science, and current challenges. And this particular course is of significant importance to the global community in the field of additive manufacturing. Additive manufacturing is defined as the layer-by-layer manufacturing of different materials with complex design and topology using a computer-controlled manufacturing process. So this process has revolutionized the field of aerospace, defense, biomedical applications, energy sectors, and so on. So this course will be of 12 weeks. So therefore, it will have 12 different modules which are structured in a very thoughtful manner so that all the students registered, all the students and other engineering personnel who will be registered for this course, they will get a fairly strong overview on the concepts of the additive manufacturing, as well as the different materials aspects, like those who do not come from the purely from material science perspective, different materials aspects, the important concepts of the engineering design, as well as the design philosophy, design platforms, topology design, and so on, and how you characterize the different materials, and that will be followed by the overview of different additive manufacturing processes, and then I will show you a number of scientific case studies to illustrate that how the field has grown across different materials, from very hard materials like metals to ceramics, and also to very soft materials like polymer-based hydrogels. So after this overview, I'll be going into a little bit more details about what I'm going to cover in different modules. I am confident that this content of this course will inspire several generations of the undergraduate students, graduate students, young researchers, professionals in industry, as well as the clinicians in the field of additive manufacturing, or 3D printing, or 3D bioprinting, or 4D bioprinting of materials of significant importance to strategic sectors like defense, or some of the other important technological sectors like aerospace and space, then areas of significant societal relevance like healthcare and so on. So I wish you enjoy this course to the fullest extent. Thank you very much. Hello again, everybody. In continuation to the introductory comments that I have made earlier on this NPTEL course, Additive Manufacturing, Process Science, and Current Challenges, I welcome you all to our department, that is Materials Research Center at Indian Institute of Science, Bangalore. This department was established in the year 1978. So I have my own research group who has been working on different aspects of additive manufacturing with a particular focus on structural as well as biomedical applications. So the name of my laboratory is Laboratory for Biomaterial Science and Translational Research, which I established in the year 2011 when I moved from Indian Institute of Technology, Kanpur to ISC Bangalore. Now, coming back to this particular NPTEL course, as I said before, that it has 12 very well thoughtful, well structured modules. Each of the modules has its own significance. For example, the first module is the very introduction to the course, where I will be emphasizing how additive manufacturing is different from conventional manufacturing, which is essentially a subtractive manufacturing process, where additive manufacturing is more like layer by layer addition. And then I'll also emphasize that what are the cost implications, and then how additive manufacturing is different in terms of producing very complex structures or components with very intricate geometries and so on, where conventional manufacturing cannot even produce such structures. Subsequently, I'll be also covering in another module, I'll be covering on the fundamentals of the materials properties, like overview of different materials, metals, ceramics, polymers, and composites, because many of you may not be familiar with the key elements and most important properties of different material classes. So, for example, I'll be introducing to the very basic property concepts like strength, fracture toughness, hardness, and so on. And thereafter, I'll be showing you that how you can characterize, how you can determine these properties. That will be kind of at the interface of module and module 2. Subsequently, I will be starting with some key concepts of engineering design, like lattice structures, cellular structures, what are the different computational platforms are used to design those kind of structures. And then I'll be moving on to the key elements or key process steps of additive manufacturing, like it will start with the design concepts, then comes that additive process optimization of additive manufacturing, then comes post-processing aspect. This post-processing can be very different when you handle the metallic materials, then it can be heat treatment or high temperature treatment, and it can be same for ceramics, but ceramics you can do infiltration, and for polymers it will be again very different, like chemical cross-linking or physical cross-linking process. So after covering all these fundamentals of the engineering design as well as additive manufacturing process, by end of module 2, then I'll be moving on to the key, some of the very important additive manufacturing process, very generic description, and that will be followed by the process science of different additive manufacturing process, like selected laser melting, directed energy deposition, what are the fundamental science that governs the quality of the additively manufactured parts that you will produce using this kind of metal additive manufacturing processes, and what are the current challenges. And thereafter, I'll be showing you a number of case studies where I'll show you how these techniques, how these SLM or DED techniques can be useful to produce stainless steel 316L components or Ti6Al4V components, titanium alloys or stainless steel alloys, and so on. And at some point, I'll be showing you the entire process from powder, metal powders to additive manufactured components using directed energy deposition process, the facility which we have established at Department of Design and Manufacturing at Indian Institute of Science. So this is the lab scale manufacturing, lab scale demonstration. And this course also will feature two invited lectures by Dr. Viswas, who is currently CEO of this MS Solutions Private Limited. We'll talk about that, what is the future of metal additive manufacturing processes, what are the current challenges, how it can be used for mass customization, how the additive manufacturing process technology can be improved so that the cost of the additive manufactured parts can go very near to that of the conventionally manufactured components. After I cover these additive manufacturing metals, then I'll move to that more additive manufacturing of ceramics. Here I'll be focusing more on the process science of a binder jet 3D printing, and as case study, I'll be showing you the case study related to the zirconia or strontium magnesium phosphate based bioceramic materials. And this process science I'll be showing you at a great depth using the synchrotron study, some of the basic analytical models, where I will show you that how binder jet 3D printing can be used for different type of materials and where binder formulation plays an important role. And in describing the process science or describing all the different components fabrication using additive manufacturing, I will be showing a number of videos which are taken either in the laboratory scale experiments or industrial scale prototype manufacturing processes, which we have obtained largely from MS Solutions Private Limited, that is based in Bangalore. And these particular videos will be very helpful to all the students in this course in order to develop a much broader understanding of the process science itself. So after completing that metals and ceramics, then we'll be moving into the more additive manufacturing of some of the prototypes. And this prototype aspect I'll be covering using that dental implants, like how one can prepare or how one can use SLA-based 3D printing technique to make the dental implants, how the properties how their microstructure can be characterized using a new technique called microcomputed tomography, which gives you 3D microstructure as opposed to two-dimensional microstructure, which every material scientist know that you can generate it using the scanning electron microscope, for example, or transmission electron microscope. Now, one of the major part of this particular NPTEL course will be related to the 3D bioprinting or 4D bioprinting of soft hydrogel materials. So here one has to appreciate the rheological properties of the soft materials, and therefore I'll introduce the key concepts of the rheology in terms of different viscoelastic properties, as well as shear thinning properties, thixotropic properties, and so on of soft hydrogels. And I'll show you through different scientific case studies as how rheological properties can be used for defining the 3D extrusion printing parameters of gelatin-based different hydrogel formulations. So thereafter, I'll be covering some very basic concepts of the space bioprinting, what are the current challenges, and more importantly, in almost more than one module, I'll be showing you the data science concept, that how machine learning can be used to for process optimizations, and here both regression and classification algorithms can be useful for additive manufacturing in general. And since many of you will not have may not have the fundamentals background on this data science, I'll be covering all the key concepts of the data science, including regression and classification algorithms. So I'll close this talk, close this particular NPTEL course by showing you a number of challenges with clear definition of these challenges, which restrict the continuous progress of the field of additive manufacturing, and I'm sure many of you will be inspired to address those challenges in your own profession or in your own research area. And this course overall will have around 60 lectures, and they will have 2 industry expert lectures and 2 laboratory demonstration of the one on the metal 3D printing and one on the 3D extrusion printing. So all together, I feel that this NPTEL course will not only provide you deep academic insights into the additive manufacturing subject as well, but also it will give you a lot of practical aspects, like how you can do research in the laboratory, what are the things to optimize, how to do the process optimization, and more importantly, how artificial machine learning is going to revolutionize the field of additive manufacturing. I wish you will truly enjoy this course, and all the best to all of you. Thank you very much.